What about this? Oh, negative. So technically, we don't know what a is. A could be a negative, could be a negative. We don't know what a is. So we're going to simplify this. But remember, it's a square root. So we can't take that out. We'll leave that inside. Okay. Now this 14a, it's both being squared. So if you think about what we just did, remember there's a 2 out here, an imaginary 2. We don't put the 2 out there. We just assume that it's there. But I'm just going to put it there so we have a reference right now. Okay, I'm just going to put a 2 out there. So remember, what does this say really? We've got two 14a's. So if we have two 14a's, well, what happens with these 2's? When we divide, 2 divided by 2 is 1. So if I have, and I'll visualize this one for you, we've got 14a times 14a. That's what it means, right? We've got two 14a's. The pair escapes as 1. Same idea here. 2 times 2 is 1. So you could have just gone right to 14a. And what's left under the radical? The negative 1. And if you remember, what's square root of negative 1 equal? I. Okay, so just remember that. That's just something from the past. 14ai. Okay, what do you think? If you're not sure how to do the 2 divided by 2, remember, write it out. There's two 14s, so 1 comes out. There's two a's, so 1 comes out. It all works the same. All right, another square root. Oh, how boring, just square roots. So boring. Let's find a fancier color. I haven't used purple. It's one of my favorites. All right, what's the square root of 16? 4. M squared. Remember, there's a 2 out here that we don't think about. So basically it's saying how many pairs of m do we have? We have 2 m's, so we have a pair of 2's. 2 divided by 2 is 1. Square root of 25? 5. Isn't it crazy how some of them take this much work to do, and some of them are just that fast? That's radicals for you. You never can tell. Sometimes they're just easy to break out of, and sometimes they're not. This one, all right, a little interesting, more interesting. So we'll deal with the roots later. It's a negative, but remember it's an odd root, so the negative is fine. The negative can come out because anything times itself 3 times, negative, 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 is going to be negative. Okay. 64. There's our tricky one. 64. We want to break it down until we've got 3 of something. So what's 64? Oh, how many times have we done 64? We know what it is. Should we do it all out again? Oh, all right. But you guys remember what 64 is from before? And if you said 2 to the 6th power, you're correct. I missed it. Why does I sometimes miss the easy things? All right, so 64 is really 2 to the 6th. I'm going to just separate these by putting a dot. Not necessary. I just want to keep them separate from each other because I'm going to do each one separate. We're going to start with the 2 to the 6th. Actually, we kind of start with the negative, but then it's just a negative answer. Okay, 2 to the 6th. So how many pairs come out? 6 divided by 3 is 2. Okay, that's it. That's as simple as it gets. Oh, here's 1, 2. I need 3 to escape. I've only got 2. Sorry, r squared. You're staying put. And 2 divided by 3, it doesn't go into 3. Okay. Let's jump to our w. We've got 15 of them, which means how many sets of 3 do we have? Well, remember, sets dividing. 15 divided by 3, there's 5. Now we have to leave something behind, and That's poor old r squared. So for right now, the way we're going to write the answer is this. Negative 4 w to the 5th cube root of r squared. Now later, I'm going to show you how to rewrite that so it looks a little bit nicer. But for right now, we're good. Okay? Got a couple more just for fun. 2x to the 8th power. Remember, all this is going to the 8th power. So this is all to the 8th. And what's out here? Lonely little 2. So we just divide all this to the 8th power. 8 divided by 2 is 4, which means 4 of these would escape radical jail. And we'll just simplify it. 2 to the 4th is 16. X to the 4th is x to the 4th. There is our answer. Okay. Couple more. Square roots again. Square roots. Man, these are not very secure prisons, are they? We need to make more roots. That's okay. That's okay. This is what we got. This is what we'll deal with. The negative's on the outside. That'll stay. What's the square root of 144? Right. That's 12. If we look at m to the 8th, remember there's 2 out here. 8 divided by 2 is 4. And you've already figured it out, some of you, and that's okay. I'll catch up to you. N to the 6th. 6 divided by 2 is 3. We can't write that answer any other way. There we go. All set. Okay. Here we go. Our 5th root. Finally, something a little bit more secure, a little bit harder to break out of. We need pairs of 5 to break out. And what you'll notice is, especially when we do 5th roots and 6th roots, the whole numbers, not very exciting because you can't take like 11 and take it to the 5th power. Because what's 11 to the 5th power? Anybody know off the top of their head? 2, 3, 4, 5. It is 161,051. So if you saw that, it's 161,051, would you recognize that to be 11 if it was the 5th root? Probably not. So we don't use big numbers. We use kind of tiny numbers when we deal with roots. It makes the math okay. I mean, it's not crazy. It just doesn't, we don't need to use big numbers to understand the concept. So 32. Some of you might already know what it is. If we break this down, you're going to recognize these numbers again, don't you? These are all powers of 2. 1, 2, 3, 4. There are 5 of them. 1, 2, 3, 4, 5. Which means we've got the 5th root of negative 2 to the 5th power, x to the 5th power, y to the 10th power. That's supposed to be a 10. There we go. It's a little bit better. Not perfect. Let me fix. Okay. Let's do our 5th power magic. Our 5th root magic, shall we say. Negative, remember it's odd, so it's just going to be negative. 2 to the 5th. 5 divided by 5 is 1. 2 to the 1st power. X to the 5th. 5 divided by 5 is 1. No remainders. X. Y to the 10th. 10th divided by 5 is 2. Can't be broken down anymore. There's our answer. All right. What do you guys think? The 6th root of m plus 4 to the 6th. Well, this is all to the 6th power. 6 divided by 6 is 1. The answer is just m plus 4. Not much more than that. All right? So instead of doing radical jail, we write out 6 of them. Remember the rule. 6 under the radical, 6th root, 6 divided by 6 is 1. All right, a square root again. Boring. Sorry. Negatives on the outside stays on the outside. Square root of 49, 7. A to the 10th. What's 10 divided by 2? 5. B to the 16th. 16 divided by 2? 8. There it is. Boom, 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 boom. I'm hoping that you guys do these pretty quickly. I gave you more work than normal as far as number of problems, but I think you'll realize that It's nothing too crazy. Okay, hopefully. 343 d to the 6th. 343. Interesting. 343. My first thought is how do we break this up? 343. Can't divide it by 2. Can't divide it by 3 because 3 plus 4 is 7. 7 plus 3 is 10. So if you can't do 3, you can't do 6 or 9 or anything like that. Can't do 5. My two thoughts are 7 and 11 might be a good one here. Yeah, if I take it divided by 7, I get 49. Oh, good. And what's 49? It's 7 times 7. Okay. All right, so it's 7 to the 3rd. So let's rewrite. It's a cube root. 7 to the 3rd. D to the 6th. Now we just do our little property. 3 divided by 3 is 1. 6 divided by 3 is 2. 7d squared. Not 70 squared, 7d squared. And not, okay, sorry. I was trying to make it funny, and it turned out not to be funny, so I stopped. All right, the square root of this. Now, you cannot do this, just so you know. You can't say, oh, look, an x comes out. Oh, a 5 comes out. Well, you can't just leave the poor 10x here. That's like saying the square root of 3 plus 3. Well, that's a bad example. Let's try this. You can't say the square root of 9 plus 9. Oh, look, square root of 9 is 3. Square root of 9 is 3. 3 plus 3 is 6. Yay. Well, 6 squared is 36. 9 plus 9 is 18. The square root of 18 is not 6. Okay. Because you're dealing with properties there. You're dealing with a grouping property, and you can't take pieces of a group out. You got to do the whole group. All right, so what can we do? Anything in this case? Well, do you remember your factoring? In fact, do you recognize this as something special? Now, you might be saying, what multiplies to be 25 and adds to be 10? And some of you might recognize right away, oh, look, that's a perfect square trinomial. It's x plus 5 squared. Well, now we've broken that up. Remember, this whole thing is squared. 2 divided by 2 is just 1. There's your answer. Okay. Now we're just doing calculator stuff. And you guys probably know, you have your graphing calculators, you know where the square root button is. And if you don't have your graphing calculator, don't forget, you can turn your Android, I think your Android phone or your iPhone to the side, and you get this scientific calculator. And you're going to notice, of course, you've got a square root there. So the square root is 7.8. Just hit the square root button, and it is approximately 3 decimal places, so what, 2.793 if you round it. Negatives on the outside, so it stays. The square root of 89 would be 9.434, approximately. Okay, square roots, nice and simple. Now, how do you do nth roots on your calculator? I don't have my TI-84 emulator, I'm sorry. So I'm going to show you how to do it on this site as well. And then I'll show you how to, the button on the TI-84 that you have to hit if you don't know where it is. But you're going to notice there's buttons like this, where you have a square root but an n on the outside. And that's where you can type in your number, the 4th root, and click in here and do 25. Okay, and which is right here, 2.236. So the 4th root of 25 is 2.236. And for the next one, it's the same idea. The next one is the 5th root of negative 4. So if you hit that, then you do 5 for your 5th root, and inside you put negative 4. There's your answer, 1.319, which would round to 1.320. So on your TI-84, you hit the math button. Now if you notice, the 5th one down has a little x on the outside of the root, so you would hit 5. And you're going to notice you have the ability to type in the root and then the number. So you put a 4, And then you arrow over and put the square root of 25, or just you put 25 under the radical sign. And then that is your answer. You have something very similar on your phones, but you're looking for a button that has that. So whatever you use, find those buttons and figure those out. Okay. So that answer was, or is, I should say, negative 1.320, because it'd be 195 would round up to 20. Okay, that's how you do a calculator approximation using, and that's how you do an approximation for these using your calculator. All right, last one. This one's a fun problem. I just enjoy it. This is a formula that I actually proved way back when I was in high school that allowed me to get out of a geometry test. So it was pretty cool. I don't remember the proof anymore. It was a long time ago. But this is a formula called Heron's formula, which is how do you find the area of a triangle as long as you have the three sides. And here's the formula. And here's the formula. So you're going to need this variable of s. And s is half the perimeter. So in order to figure this out, what you have to do is you have to add these up. 15 plus 17 plus 20. And take half of it. Okay, so what do we got? 10, 20, 40. You said 52 over 2. And 52 over 2 is 26. So you take that 26, that's your key number. So your area is going to be the square root of 26. And then you take 26 minus each of these numbers. So 26 minus 15. 26 minus 17. And 26 minus 20. Now I don't expect you guys to necessarily do this without a calculator. So it would be 26 times, and what's 26 minus 15? That would be 11. And then 26 minus 17 would be 9, and 26 minus 20 would be 6. So if we put that all in the calculator, we get, so we have the square root of 26 times 11 times 9 times 6, and we get the answer of, this is round to the nearest whole number, it's 124.273. So if you round to the nearest whole number, it's approximately 124 square feet. Approximately. There we go. So that's how you use that formula. It's actually pretty cool. You don't need to become an expert at the formula, but just that's one way that square roots and radicals are used to solve regular old equations. Look forward to seeing you guys in our live session. And I will let you know when that is. And that live session is not a requirement. It's kind of like office hours for me. I'll be on to see if you guys have any questions or want any advice or just want to check in and see how things are going. So I hope you guys continue to have a good day, and I'll see you later.